Hey, Math 30-2s. Here is your next lesson in rational functions. This one is going to be all about simplifying these rational expressions. Let's take a look at how we're going to do this. Now, what we did in our last lesson was we talked about finding non-permissible values, and we found those by factoring. Well, we're going to end up doing that a lot here, okay? And a couple of small things to remember. We've always got to find our non-permissible values, and it's important that we never, ever, ever leave an answer with a negative exponent. Okay, let's take a peek at a couple of these. The first couple look very much like something we would have seen in grade 10. So when I'm looking at these ones, it's a monomial over a monomial. So really all I'm going to say is I'm going to simplify the 14 over the 4. Well, 2 is a factor of both of those. So I'm going to divide those both by 2. And then x to the power 5 divided by x to the power 2 while we subtract the exponents. Now what's really important here though is our non-permissible value, and where do I look for it? My non-permissible value, I'm going to look at the beginning, not at the end, because if I looked at the end, I would say, hey, there are no non-permissible values. That's not true. We have to look at the beginning. So if I come back and look at the beginning, what I'm going to be able to say is x can't equal 0. So search for non-permissible values before we simplify. Number 2. So same thing, I say to myself, what's a common factor of 24 and 18? 6 is. So I'm going to divide both of those by 6. That'll give me negative 4 over 3. And then in the x squared and the x cubed, well, I've got 2 x's in the numerator and 3 x's in the denominator. So when I divide, I'll be left with 1 x in the denominator. And again, our NPV, comma, x can't equal 0. There's monomials over monomials. Like I said, that's something I could have asked you to do in grade 10. Let's take a look at grade 12 now, and let's start looking at 30-2 level questions. So on a question like these ones, when I start seeing binomials or trinomials, what I'm going to do is I'm going to try to factor first. So treat the numerator and the denominator as 2 separate factoring questions. What can I factor out of the numerator? 5x. What do we have left inside here? Well, our binomial will be 3x squared minus 1. So factor. Then I'm going to say, okay, how can I simplify? Well, I can divide the 5 and the 15. They simplify. 5 goes into both of those. So that'll be 1/3. I can divide the x in the x cubed. That's x squared. And I can't do anything with the 3x squared minus 1. Now, some people are inclined to make a really easy mistake here, and they want to go like this. They want to say, hey, 3x squared minus 3x squared. Let's divide. That's really bad, friends. You can't do that. You can only divide if what you're dividing by is a factor of everything in the numerator. So although I agree 3x squared divided by 3x squared is 1, it doesn't divide into the negative 1. So we can't divide this. This is our final answer right there. Now, the only thing, again, we're missing, which we have to go and find, is our NPV. Well, coming back up to here, it's simply x can't equal 0. All right, let's try another one. 4. So again, I see a binomial, so I'm going to factor whatever I can out of it. It looks like we can factor out a 3x. So I'm left with 1 minus 3x in my binomial, just like that. And now I can divide. So once I can factor, I can divide. 3 over 6 simplifies to 1 over 2. X divided by x cubed is x squared. And again, the numerator here, I can't do anything with that 1 minus 3x. NPVs, right there, x can't equal 0. Okay, so we can see again, we can only divide if we can factor. divide if we can factor. Okay, try a couple more. Now, I see binomial over binomial here. So what I'm going to search for here is factoring the numerator and the denominator again as two separate questions. Numerator, greatest common factor is 2x. And what will we have left? 3x minus 4. From the denominator, greatest common factor looks like just x to me. Oh no, x squared. What will we have left? 3x minus 4. Okay, friends, I know I'm doing this question right because I see binomial factors that I'll be able to divide out. Keep simplifying. Well, what do we have? 3x minus 4 and the 3x minus 4 will divide out. 2 in the numerator, x divided by x squared is x. Look at that. Made my division sign way too long there. Just a little smaller. Okay, non-permissible values. Well, my non-permissible values, I'm going to look at the factored form here. Right there, I'm going to say x can't equal 0. And right here, I'm going to say 4/5. There it is. There's our answer. All right, let's try another one. So on number 6 here, binomial in the numerator, but nothing I can factor. Denominator, that's a difference of squares. So I need you to recognize that. And now again, I see the 2x minus 1 divides by 2x minus 1. And again, what I'll see on occasion is I'll see a student just write, oh, awesome, I'm left with just 2x plus 1. Be really careful. The 2x plus 1 is in the denominator. All right, NPVs. Well, switch to pretty red here. That one, x can't equal positive a half. This one, x can't equal negative a half. So I'm going to simply write it as positive, negative a half. That's it. This is how we simplify rational expressions. So again, your steps, your first step should be factor everything. I can only divide if I can factor. Step 2, find my MPVs. Step 3, simplify. And how do we simplify? By dividing. That's it, friends. That is how you simplify a rational expression.